All right, we're getting close to the end here. Number 40 tells us to graph the solution set of the system of inequalities. And we've been given 2x plus y is greater than or equal to 4, and x minus 1 is greater than or equal to 0. So let's go ahead. We're going to graph each of these inequalities here on the xy plane. And to start off, let's go ahead and graph this first inequality. 2x plus y is greater than or equal to 4. All right, and when you're graphing inequalities, sometimes it's a little intimidating to see this inequality symbol. So let's pretend just for the moment that instead of graphing this inequality, we were simply graphing an equation, 2x plus y equals 4. And in this case, how would you graph this equation? How would you graph this line? Well, we could do one of a couple things. We could either put this into y equals mx plus b, which I feel like we've been doing a lot this practice test. So let's go ahead and use an alternative method. Let's find our intercepts here. All right, so if we're going to find the intercepts, let's quickly set up our little xy table. Do a little neater than that. All right, and so we know if we're going to find the y-intercept, we have to plug in 0 for x. So let's plug in 0 for x in this equation. So 2 times 0 plus y equals 4. All right, 2 times 0 is 0, so that goes away, so we're left with y equals 4. All right, so when x is 0, the corresponding y value is 4. And now lastly, let's go ahead and solve for the x-intercept. And we're going to do that by plugging 0 in for y to find the corresponding x. So we'll have 2 times x plus 0 equals 4. That 0 goes away, just leaves us with 2x equals 4. And if we divide by 2 on both sides, that gives us x equals positive 2. All right, so when y is 0, the corresponding x is 2. And now that we've filled in our xy table here, we know these simply become points, don't they? This becomes the point 0, 4, the y-intercept, and this becomes 2, 0, the x-intercept. So let's go ahead and graph these 2 points. So 0, 4, and 2, 0. All right, well, now that we've got 2 points, we know we only need 2 points to create a line. But be careful, because remember, we started with an inequality, didn't we? We didn't start with an equation. So when we connect these 2 dots, we have to make sure that we use the correct line. All right, and recall, when you're graphing inequalities, if you have less than or equal to or greater than or equal to, when you graph, you're going to graph with a solid line. If you have simply less than or greater than, you will graph with either a dashed or dotted line. All right, in this case, we have our inequality is greater than or equal to, so when we connect our 2 points here, we will use a solid line. Oops, oh no, where'd it go? There it is. All right, and of course, that is not a very good line at all, is it? And it's somewhat difficult to do a line freehand. All right, so there we go. Now, don't forget, with inequalities, we have to determine where we're shading. Are we going to shade above the line, or are we going to shade below the line? And in order to determine where to shade, we have to use a test point, all right? And a good test point to use is 0, 0, the origin, because it's easy to work with zeros. And recall that you can use any point to test, so long as the point you're looking to test does not fall on the line, does not fall on the graph. So we can clearly see if we're going to test 0, 0, that point, the origin, does not fall on the line. So that's a good point to test. So let's test 0, 0. And what we're going to do is we're going to take this point, this x, y, plug it into the original inequality that we were given and see whether or not we get a true statement. So if we plug it in, we have 2 times 0 plus 0 is greater than or equal to 4. Well, 2 times 0 is 0, that goes away, plus 0, that goes away. So on the left-hand side, we're simply left with 0 is greater than or equal to 4. Is this a true statement? Is the number 0 greater than or equal to 4? No, that's not true. That's false, right? And so since the point we chose to test was here at the origin, below the line, and we got a false answer, that means we have to shade on the opposite side of the line, so above the line. So we're going to shade above the line. All right, and I'm just going to go ahead and use little arrows to remind me where we're shading, because at the end of our problem, once we've graphed and shaded both inequalities, we have to look to see where is the graph double shaded. The double shaded portion will be our answer. And it's nice sometimes to use these smaller arrows to indicate where you're going to be shading, because it makes your graph a little easier to read. If you have a whole bunch of graphing going on, shading going on, sometimes it can be difficult to read the graph, but these small indicating arrows are helpful. All right, so we just graphed the first inequality. We know we're shading above the line, so we've got the first inequality down. I'm going to go ahead and get rid of all of this, and we'll take a look at the second inequality here. So we have x minus 1 greater than or equal to 0. Here we can see we only have a single variable. We only have x. So let's go ahead and get x all by itself. We'll do that by adding 1 to both sides. That leaves us with x is greater than or equal to 1. Let's go ahead and graph this line. And what I should do to make it a little easier to see is, let me use a different color. We'll use green. All right. So x is greater than or equal to 1. Well, again, if this inequality kind of scares you a little bit, pretend that instead you're graphing x equals 1. And how would you graph that line? Well, that's just a vertical line going up and down through the x-axis at positive 1. And again, we're going to graph this line with a solid line because the inequality is greater than or equal to. So here's positive 1 on the x-axis, and we're going to have just a solid line. And again, we'll pretend that line is straight. All right, and now we have to determine which side of this line to shade. Are we going to shade on the left-hand side of the green line, or are we going to shade on the right-hand side of the green line? Well, we could use a test point if we wanted to. We could use 0, 0 again, the origin to plug in. But when you have a single variable, when you have either a horizontal line or a vertical line, sometimes it's easier just to read what this inequality says and shade based on what this inequality says. So this says x is greater than or equal to 1. So let's go back to the graph. Where are all the x values, so the x values on the x-axis, where are they bigger than, greater than, or equal to 1? To the right of the green line or to the left of the green line? Well, we can clearly see that to the right of the green line, the x values are greater than or equal to 1, right? Because here's 1, to the right is 2, 3, 4, 5, 6, etc. Those are all greater than or equal to 1. But to the left, we can see that the x values get smaller. So we don't want to shade on the left. We're going to shade to the right. All right. And now that we know where we're shading for both of our inequalities, we have to determine which section of the graph is double shaded. All right. So let's see. Well, here the blue inequality, this blue line, we're shading above the line. And for the green inequality, we're shading to the right. And so if you look, we can see that this section here, and that's not very bright, let's get a different color. We can see that this section here will be the double shaded portion. All right. So again, we're only looking when we're graphing two inequalities and the directions are to graph the solution set. We're only interested in the portion of the graph that's double shaded. And so this portion of the graph that I've just shaded there in gray is the only portion of the graph that is double shaded, because notice down here in this little white triangle here, if we were to shade, only the green inequality has shading in this area because the blue is shaded above. So this only has a single shading, green shading. Here in this upper triangle, we would only have blue shading, right? Only in this gray area does the shading overlap. It's double shaded, and so that's what we're looking for. And you can go ahead and in your double shading like that, if you want, you can put in black or some other color, you can make a dark A for answer. Sometimes that's nice, but definitely you want to indicate on your graph that this is the portion of the graph that you are claiming to be the solution set. So make this part of your graph dark, and then you can, if you want to, go ahead and put a dark A for answer in on your graph there. So there's number 40. We graphed both inequalities, and we chose a test point for the first inequality that helped us to determine that we were shading above the line. We graphed the second inequality, and we were able to determine that we shade to the right because x values that are greater than or equal to 1 are to the right of that green line. And then we looked to see where was the double shaded portion, the portion of the shading that was overlapping, and that's the gray area there. So number 40.